at the global scale, and this is going to increase the demand of certain critical minerals significantly. And for instance, if we can take an example of the electric vehicles and renewable energy, the growth of this sector is expected to increase the demand for the batteries, especially the lithium-ion batteries. And this in turn will create a greater demand for the critical minerals such as lithium, cobalt, nickel, manganese, and graphite used in these lithium battery variants. And given the current demand projections and technology trend, we may struggle to meet the demand for these some of these critical minerals in future. For example, it is expected that we may fall short for the lithium by 1.1 million tons by 2035. But some estimates suggest that battery recycling could potentially reduce the global primary mining demand by 55% for copper, 25% for lithium, and 35% for cobalt and nickel by 2040. So this highlights the importance of battery circularity, that why we need to give importance to this battery circularity discussion, and we need to take enabling action so that we are able to integrate the battery circularity at the different stages of LIB supply chain. Globally, if you see the current, the majority of the feedstock for the battery recycling industry comes from the production waste. But this is going to shift towards the end of life batteries by 2030. So, as I mentioned, if we integrate the circularity with the battery supply chain, this will help us in securing these critical minerals from this end of life batteries, and this will help us in reducing reliance on primary mining and lessening the environmental impact of the battery supply chain. So in the context of India, if we see the lithium battery market relies on import, and efforts are underway to establish a domestic lithium battery industry, manufacturing industry. And to create a sustainable battery ecosystem in India, it is crucial to incorporate circularity at various stages of LIB supply chain, starting from manufacturing to end of life recycling. And in this context, it is important to assess the raw material recovery potential from end of life recycling in India. So globally, we have enough data about the potential of recovery of raw material from recycling, reuse potential. But in case of India, we need to assess that what is the potential to recover the raw material from recycling, what is the potential for second life application of retired EV batteries, where is the gap in policy and regulation, and we need to understand challenges related to the market development and technology. And based on this understanding, we need to develop a India specific strategies for battery circularity and pathways to fill the gaps related to the policy, regulation, standards, and implementation plan. And for this, we need a research-based solution, and we all need to work together to find the solution. So as part of this project, we are evaluating the potential for recovering raw material from LIBs used in the electric vehicles and battery energy storage system in India through end-of-life recycling. We are also identifying gaps in the current policy and regulatory framework, and we'll be also working on the development of strategies for implementing battery circularity in India. And during today's meeting, we'll present our assessment of LIB demand for the electric vehicle and renewable energy sector by 2030. And this will be followed by a breakout session for detailed discussion. And we'll conclude with a discussion on critical aspects related to the policy and regulatory framework. So I will not take much time. I will hand over to Anandita for the presentation to see uh, our research work, what we have done in past 3-4 months, and then we can continue on the discussion with that. Over to you, Anil.
Thank you, Dr. Parveen. Now, I would request Mitradev Sahu, Junior Program Associate, WRI India, to give a short presentation on the LIB demand and critical mineral requirements in low carbon technologies in India. Over to you, Mitradev.
Thank you, Anandita. I'll be sharing my screen. Hope my screen is visible.
Yes.
Okay. So we are going to discuss here about the material baseline assessment for lithium-ion batteries in low carbon technology adoption for India. And these are the broad outline that we are going to discuss. And the major battery assessment we are doing in terms of two fields, which are the electric mobility, electric vehicles, and battery energy storage system. So considering this, we'll see what are the EV cells projection, what is the battery capacity requirement. Similarly, in BESS, what is the capacity addition of the battery energy storage system for BESS, and what is their technology mix and total lithium-ion battery requirement in both the sectors, and what is the raw material available in these batteries, or we can say the deployed amount of lithium-ion battery. And then we'll see what are the expected life of these LIBs in this different application. And for this, the analysis we have done, for that we have also done some literature review where we have tried to compare our analysis or our result with those results. So that we'll also discuss as part of this presentation. So why are we just discussing about this? As I already mentioned, this electric vehicle and battery energy storage system, because transportation sector and the energy sector are among the top two most emission causing industries, if we see. And currently the adoption of electric vehicle in the transportation sector and renewable energy in the energy sector, both these industry are moving towards decarbonization. So, and lithium-ion battery actually plays a big role for this decarbonization drive. Like for the electric vehicles, lithium-ion battery are the most popular choice across the vehicle segments. And similarly, in terms of renewable energy, for the renewable energy integration, BESS, battery energy storage systems, are being used, and they are also lithium-ion batteries are the most popular choice. And once this battery complete their lifespan, they will be retired, considering different criteria, their chemistry, degradation factor, all of this. And those batteries can be recycled, and those recycled material can be utilized for the domestic manufacturing of new batteries. So we'll see what is the potential of those materials. So this is the overall the objective of this project, overview of the project. And so to achieve that result, this is the methodology that we have adopted for the electric vehicle cells or the EV battery adoption in the electric vehicles. What we have done, we have projected all vehicle cells. Then we have projected the percentage penetration of electric vehicles in those segment. Considering both this number, we have got the EV cells requirement, and considering the average battery capacity for individual vehicle category, what will be battery capacity will be calculated, that we have estimated. Considering the vehicle models, OEM-wise vehicle models, we have and the chemistry of the battery they use. Considering that, we have tried to assess what is the battery technology mix for the EV sector. And similarly for BESS segment, we have reviewed a lot of literatures from where we have got what is the energy storage requirement in India. From there, we're considering various literatures. We have tried to estimate the BESS LIB requirement and the technology mix for these LIBs. So when the LIBs in all these applications are going to be retired, considering their lifespan. We can end their battery technology. We can assess the annual total retired battery, and with the battery technology being known, we can estimate the volume of the battery material that can be that we can get from these retired batteries. So before going into the analysis, here are few of the broad boundary condition assumptions that we have considered. I will just tell few of the major boundary conditions. I don't want to read everything. Like, this is a complete numerical model, and as we are discussing about only the business as usual scenario, it doesn't consider any further change in the policy regulation, or that upcoming speculation are not being considered yet. But with the development of optimistic scenario, we'll be further developing a few of those. And similarly, data for the EV cells is collected from Vahan portal, so it misses out data from Telangana and Lakshadweep. And similarly, we have not currently included the replacement batteries. Only the new battery, or those are being sold with the new vehicles, or the battery BESS capacity addition application, those are being only considered. But as part of the further analysis in this project, we'll be doing that, and we'll be also again discuss the final results with you. But currently, as part of this project, we'll be only discussing the total battery capacity estimation or required for this transportation and energy sector requirement. Also, the battery technology mix in the both the segments. With that, what is the total battery material that is in deployment currently? So these things we are going to discuss with you. So giving the brief summary of the vehicle EV cells projection, I'll just we have categorized the vehicles into two-wheeler, three-wheeler, four-wheeler, bus and freight segment. Further, we have classified those vehicle segment into different vehicle classes, such as for two-wheeler, high speed, low speed, for three-wheeler, rickshaw and auto. Similarly, for four-wheeler, this is passenger car, a cab, and bus, light, medium, and heavy buses. For freight, light, medium, and heavy goods vehicle, we have classified them. And considering that, here we have just tried to capture what is the 2023 EV adoption rate, and what is the expected EV adoption by the year 2030 according to our analysis. So giving a brief overview, in the two-wheeler segment, we are expecting around 27 or 28% EV adoption by the year 2030. In the three-wheeler segment, we are expecting around 92 to 93% EV adoption. In the four-wheeler segment, we are expecting around 32% EV adoption. And in the overall bus segment, we are expecting around 16% EV adoption. In the freight segment, we are expecting around 9 to 10% EV adoption. Considering all the vehicle segment, we are expecting 30 to 31% EV adoption by the year 2030. And if we see the all vehicle sales in India, currently it is around 2.35 crore total vehicles sold in the vehicle categories that I mentioned before. And in these segments, the total vehicles sold we are is going to be sold around 5.2 crore by the year 2030 we are expecting. And considering the EV adoption rate that I previously mentioned, we are expecting around 1.54 crore total EVs by the year 2030. If we see the current figure, it is just around 0.17 crore in the year 2023. And if we see the contribution of this different vehicle segments to the total EV sold, in the current status, if you can see, currently two-wheeler segments are leading with a share of around 56%. But by the year 2030, that is going to change, and two-wheelers contribution are expected to increase more with a share of around 70%. Similarly, three-wheeler are currently the second highest contributor to the total electric vehicle sales, which account for around 37 to 38%. But by the year 2030, their share is expected to reduce from 37% to around 15 to 16%. In the four-wheeler segment, current contribution is around 5.4%, but by the year 2030, we are expecting their contribution is going to increase significantly, which is around from 5% to 12% we are expecting. Similarly, for buses, their current contribution is also less, and by the year 2030 also, it is going to reduce a little bit further. And freight segment also, we are currently their contribution is around 0.29%, but they are also going to expected to increase 5 times to around 1.5%. And considering these vehicle segments, here we have estimated the average battery capacity of this different vehicle segments that we have considered. For example, for two-wheeler segment, as I have already mentioned, we have further classified them into light, high-speed and low-speed vehicles. So in the high-speed vehicle, we are expecting a average battery capacity of around 3.23 kilowatt hour, and the low-speed vehicles 1.42 kilowatt hour. In the three-wheeler segment, we have classified them into rickshaw or auto segment, or which broadly we can say L3 and L5 segment. In the rickshaw segment, we are estimating a average battery capacity of around 4.7 kilowatt hour, and in the auto segment, we are expecting a battery capacity of around 5.75 kilowatt hour. In the four-wheeler segment, the car segment, passenger car segment, here we are expecting a average battery capacity of 36 kilowatt hour. In the cab segment, it is around 27 kilowatt hour. In the light bus, it is around 131 kilowatt hour. In the medium buses, around 174 kilowatt hour. In the heavy buses, it is around 251 kilowatt hour. And in the goods segment, similarly, in the light goods segment, the average battery capacity is around 21 kilowatt hour. In the medium freight segment, it is around 72 kilowatt hour. And in the heavy freight segment, it is around 265 kilowatt hour. So considering the total vehicle sales that we have previously seen and this average battery capacity, we are estimating battery capacity requirement of around 127 gigawatt hour in the year 2030. And if we see the cumulative requirement between 21 to 2030, we are expecting around 440 gigawatt hour between 2021 to 2030 in the EV application alone. So now I have considering then what battery chemistry those vehicle segment are utilizing currently. If we see the current status, two-wheeler segments, NMC battery chemistry is dominating. In the E3-wheeler, which is the L5 segment, auto segment, there, and the four-wheeler segment, bus segment, and freight segment, LFP battery chemistry is dominating, followed by NMC battery chemistry. In the but in the E3-wheeler rickshaw segment, which is the L3 segment, their lead-acid battery is still dominating with a share of around 73%. But they're the second favored battery chemistry in the L3 or rickshaw segment is LFP batteries, which has a share of around 27% currently. And e-buses also have some other lithium-ion battery application which are using LTO batteries as well. So they have a share of around 7%. And similarly, if we see all the combined battery technology mix, currently the EV battery market, if we see 82% share is with lithium-ion batteries and 18% share is with lead-acid batteries. And if we see the split of this lead-acid battery market, here we can see LFP has a share of around 54%. NMC battery chemistry has a share of around 37%, and around 9% is with other battery chemistry, which uses NCA, LMO, LTO batteries in this two-wheeler, three-wheeler, and some in bus segment also. And with the change in number of vehicles in different vehicle categories, as we have already seen, the two-wheeler, four-wheeler, and freight segment was increasing, whereas the rickshaw and bus segment was share was decreasing. So considering this, when we are projecting the battery technology mix for the year 2030, here we have taken a major assumption, like the vehicle categories or vehicle OEMs, the battery chemistry they are currently using, they are going to use the same battery technology by the year 2030. So considering this, the overall battery technology mix is changing. And if we see the change between 2023 to 2030, here we can observe the LFP share is increasing from 54% to 61%. The NMC share is decreasing from 37% to 32%. Whereas the other lithium-ion battery chemistry share is reducing from 8.5% to around 6.3%. And as you have talked about the battery requirement and battery technology mix for the EV segment, now coming to the energy segment, or where we're talking about the BESS adoption. If we see the current status of India for the BESS, there is around 5.6 gigawatt hour of battery energy storage system in pipeline, out of which only 4% are commissioned or installed, which accounts for only 216 megawatt hour. And if we see the CES report, there we are means they suggest a requirement of around 208 gigawatt hour of battery energy storage system by the year 2030. So if we see the requirement of 208 gigawatt hour from 216 megawatt hour currently, it is a CAGR growth of around 167%, and it is a huge requirement. And in terms of battery technology, what battery technology they are currently using, if we see, currently out of the 216 megawatt hour, around 91% are using the lithium-ion battery. 7% are there, is giga capacitor, but that is a pilot project. And the share of vanadium flow battery and the lead acid batteries are actually very less. And if we see the trend for 2030, we are expecting a similar trend. Currently, it is around 91%, and by the year 2030, we are expecting around 90 to 97%. And in the and for our further analysis, we are going with the base case scenario that here I tried to plot, where we are assuming like 97% of the lithium and 97% of the battery energy storage system are going to utilize the lithium ion battery, which can account for around 201.9 or 202 gigawatt hour by the year 2030. And if we see the battery technology mix year on year, we can observe like the share of LFP in the battery energy storage system is also huge. And it is, according to our analysis, it is decreasing a bit, but not that much. And the share of NMC might also increase. And if we see the average or the cumulative requirement here, LFP can account for a share of around 90.2% out of this 202 gigawatt hour that I talked about. And NMC can have a share of around 6.5%, and NCA chemistry can have a share of around 33.3%. And if we see combined battery requirement in both BESS and EV sector, we are expecting a total LIB requirement of around 218 gigawatt hour in the year 2030, which can account for a cumulative requirement of around 640 gigawatt hour between 2022 to 2030. And in the cumulative requirement, the majority of the share, which is around 68%, only EVs are going to account, and only 32% will be contributed by the BESS. And here an interesting observation, if we can see, like in the year 2023, majority of the application was coming from EV application from both the sectors. And but by the year 2030, the BESS is going to have a significant share out of, like, currently around 99% share is with EVs, but by the year 2030, around only 58% will account for by the EVs, whereas 41% demand will come from BESS. And if we see the cumulative battery technology mix, considering both the segments, the share of LFP battery are going to increase. Like from, if we see in the year 2023, overall share of LFP is around 49% in the total LIB market, but it is expected to increase to around 73%, where the share of NMC is expected to decrease from currently 41% to by the year 2030 to 22%. Similarly, other LIB chemistry is also expected to decrease the share of other LIB chemistry. And now that we know the battery requirement, battery technology mix, and considering the composition of this different battery chemistries, we can assess how much battery material is in deployment currently. So here we have assumed like where the NMC battery technology we are talking about, only NMC 622 battery we are considering, and where we are talking about LTO batteries, we are considering only LMO LTO batteries. So here if we see like this LFP batteries and this LMO, which uses the graphite anode, those battery has the least lithium requirement, but When we are if we see only the LMO segment, where considering the graphite and LTO anode, when the anode is changing from graphite to LTO, there the requirement of lithium is increasing by around 2.5x, where the manganese around 1.5x. And if we see the nickel or cobalt heavy batteries, like NMC, NCA, there you can see the share of nickel is highest among all the cathode material if we see. So considering this battery composition, here you have tried to capture what is the lithium-ion battery material in deployment currently, and here you have tried to capture it in cathode and anode segment. So if we see the demand for this lithium is alone going to increase by 24 times by the year 2030 from 2023. The nickel, cobalt, and graphite demand is expected to increase around 17x by the year 2030 from 2023. And similarly, graphite demand is going to be increased by around 25 times by the year 2030 from 2023. And when this much battery material now we know that those are available, and those battery material are not going to be retired simultaneously, and those are going to retire phase by phase. And those phase will come according to this the life of battery in this vehicle segment or in this BESS application. So here we have tried to capture the expected battery life of this vehicle segment or this BESS or this lithium-ion battery in different application, and what is the warranty provided by this by different OEMs. So here we have just tried to put a comparison between them. What is the, for example, for two-wheelers, the lithium-ion battery has a warranty that is provided OEM is around 3 to 5 years. But if we see their expected life in different battery chemistry, and according to their application, like personal and commercial application, that if we see the NMC battery chemistry alone, so in the two-wheeler segment, they have an average lifespan of around 5.3 years in the personal application, where in the commercial application, it reduced to around 2.6 years. Similarly, in LFP case, the expected life for personal application is around 5.7 years. And by the year 20, in the commercial application, it is around 2.8 years. And for the NCA chemistry, the expected life in the personal application is around 6.6 years. And in the commercial application, it is around 3.3 years. Similarly, if we see the in the three-wheeler rickshaw segment, warranty is usually provided 1 to 3 years, where the expected life is only 1.25 years. Considering for this expected battery life, here just to before talking about further, this expected battery life are actually considered based on like warranty what are being given by the OEMs, what are the average travel distance by this vehicle categories, and what are the observed degradation pattern of this battery chemistries. So considering this, that we have tried to capture here. And similarly, in the four-wheeler segment, if we see the average warranty is given 7 to 8 years, but expected battery life in the personal car segment, we are expecting around 10 years. But in the passenger car segment, we are expecting passenger cab segment, we are expecting around 3.5 years. For buses and freight, assumption is kind of similar for now. So here in the NMC battery chemistry, we are expecting their life to be 3.3 years to 4 years. For LFP batteries, around 6 to 7.3 years. For LTO batteries, it is around 12 to 16 years. And so this is the average battery expected life that we are considering. And as part of our further analysis, we'll be doing based on this expected battery life, how much battery material are going to be available by the year 2030. Year-on-year analysis that we'll be doing, and what is the potential that India can generate its own secondary supply chain for these battery materials that we'll be estimating. But before going to that, to put where our analysis stand in the industry. So as I have already mentioned, we are only assessing two sectors, which are EV and BESS. And the studies that we have found, they are multiple applications. Like few studies, they are only using for the assessing for the EV application, whereas there are few studies which are assessing for all the application like EV, BESS, and consumer electronics. So if I just compare our results for the year 2030, in the year 2030, we are expecting around 218 gigawatt hour, and it is kind of we are finding ourselves in the same range as other analysis as well. And if we see the battery technology mix as well, and here it is kind of interesting for me, like in the global scenario, if we see, majority of this report suggest NMC battery are going to dominate. But if we see Indian, what is Indian aspect, here we can see here there are broad assumptions. Few studies suggest that where LFP are going to dominate, and few study also suggest where NMC chemistry are going to dominate. But currently, our study, the existing scenario, and considering the assumption that same battery technology are going to be used by the OEMs and BSS industry. So this is the battery technology mix, which says LFP battery chemistry are going to dominate. This is what our study also suggest. So like this is kind of one-way conversation from my side, but before going and we need your inputs for this analysis that we have done. So before going into that, we'll just want your feedback, and here we have tried to put few questions, and those questions will now show up on your screen. So like what are your opinions based on like few questions we have found based on EVs, battery technology mix, and BSS. So if you can just spend 5 minutes of the time and just give your opinion. What do you think? Uh, or what is your opinion for these questions?
I'm launching the poll.
Yes, please.
Would request everyone to please participate because right now I see very few people have actually answered. One more minute and I will end the poll. So please, whoever has not put in their inputs, request you to please take the poll.
Yes, please take the poll. So these results are going to that these results will definitely help us for our analysis further. And yes.
Okay. I will close the poll now. We have about 26 people who have participated. Do you require another minute or can I end the poll? Okay. Thank you very much, everybody.
Thank you so much for your answers. But as going to the next part of this uh, discussion, uh, will be uh, going like to discuss what I have just now presented currently about EV and BSS. So now we are going to, if you have any questions, keep your questions ready, and so that we can discuss. And if you have any concerns related to this analysis, we can discuss those things in these two breakout groups. And for the two breakout group, I just have to mention, like, one is for EVs and another is for BSS. And in this breakout sessions, here we are just going to discuss about how more detail about how the results that I've just presented, how we have arrived to those results, what are the assumptions that we have considered, and what is the current scenario and what can be the future scenario. And so yes, we want your opinion. Also, we want your questions. Same, both the things at the same time. And like before going into the polls, I'll just request Anandita to put some things about the breakout groups in detail. Anandita.
Yeah, hi. So give me a couple of minutes and I will assign people to each breakout rooms. And I would request the leaders of breakout group 1 and 2, that is Dr. Parveen and Anurag, to please record the session in your, just hit on the recording button so that the rooms also get recorded, the breakout rooms. So please bear with me for a couple of minutes because we have a few new joinees and I want to assign them to the right room. Thank you.
And if you just don't find yourself in any of the breakout rooms, just hold on with us for 2-3 minutes so that, like, we can assign you to breakout groups. So just yes.
Anandita, you are not audible.
Yeah, sorry. Is everybody in their break rooms? Hi. I hope everybody is in their respective breakout rooms now.
Hi, Anant. Hi, Anant. Please assign me in group one.
Oh, okay. Just a minute. You are already
You can share the screen. Yes. We can start the session.
Abhishek, you haven't got the invitation, is it?
No.
Um,
Also, Prashant Kumar Upadhyay is also waiting.
I have assigned him. Abhishek, you're in group 2,
No, group one.
group 1, right? You are already, you have not joined the invitation. You are already in group 1.
I am not getting anything.
It says you have joined, karke.
But I am not in the meeting one right now.
Okay.
Just okay.
I've put you on 2 and then I'll move you to 1.
Hello, Ananta.
Yeah, did you get an invitation for one?
I got invitation for two. I want for one.
You check, you would have got for one also. Join two, and I will put you back in one. Hi, Mr. Upadhyay. Did you get an invitation to join one of the breakout rooms? So for folks who have just joined, we have a breakout room discussion going on, and I'll put you in the rooms in just a couple of seconds. I hope you've got the invitation for the breakout room. Hi, everyone. Sorry to disturb. We just have a minute more and the rooms will be closed. Thank you. I hope you all had a good discussion. If you can please turn on your videos, would be great just to thank you. I would now request Dr. Parveen and Anurag to please summarize the breakout sessions.
Thank you, Anindita. So, in the breakout session, we shared few questions that I think, if Mitradev possible, please share on the screen. So, we shared this question and try to get the feedback on this number, that whether these numbers looks okay, or our guests are having any suggestion on this. So overall, all are okay with the numbers, whether it's related to projection and technology mix. And we got few suggestions, especially related to the bus, that that from the switch mobility, there is a suggestion, means opinion, that bus penetration may reach to 20% with the government policy interventions. And heavy trucks, we can see 5 to 6% of penetration. And then there is a suggestion on the electric two-wheeler that penetration may go up to 30 to 40%, both high and low combined. And electric three-wheeler, there is a suggestion that we can see a significant penetration, almost 70 to 100% kind of thing. And the average battery capacity may increase from 10 to 12 kilowatt hour, especially in the cargo segment. And one question was about the battery swapping. So there is no clear answer. But because why we asked this question, because we think if the battery swapping is going to have a significant share in the electric two-wheeler and electric three-wheeler segment, So this is going to impact our overall battery capacity assessment for the EV segment. So that's why we are asking. So any input on this in the chat or via email after this meeting will be really helpful for us. And on the technology mix side, eBus, there is a suggestion, there is an input that the LFP is going to dominate the technology mix. And on the battery life, you are looking for some numbers, how much battery life we can expect in the different EV segments. And we were trying to get opinion on that, whether our numbers is reasonable or we are underestimating or overestimating. There are some few suggestions, but I think we need more inputs, and I will request the experts if they can share via email after the event, or if they can share in the chat. So these were the some of the inputs, and then I will request Anurag for the BSS session. You can summarize it.
Thanks, Parveen. So starting off with the capacity of BESS required for the Indian grid, there is a very clear sort of understanding that all of this might not come from LIB. There is going to be a role of pump storage as well. And the pump storage being larger in capacity and having a slightly larger requirement on several fronts, including land and gestation period for construction, could be a competitor to LIB for grid-connected BESS primarily. This also is, I think, going to be augmented by behind-the-meter battery storage. OEMs as well as experts from the battery industry have pointed out that there is a likelihood that you could have behind-the-meter BESS applications picking up quite significantly. There was also mention of time of day tariffs, which are now starting to kick in at various states, and this could accelerate behind-the-meter storage applications. So there is a potential that along with grid-connected BESS, behind-the-meter storage applications could also start creating significant capacities in the country. In terms of the technology that is going to be used for these battery storage assets, while LIB currently does dominate, it's going to be a mixed market where other technologies are also going to start creating niches for themselves, or start going to create, they start penetrating the market. So I don't think that the group was entirely convinced that LIB will continue to dominate, but there is going to be other alternative chemistries that will play a role in the battery energy storage segment. LIB's share over the next 6 years is definitely very clear. It is going to be there. It's not going to be phased out. But there will be other battery technologies which will sort of slowly start to step up and maybe take a little bit of share away from the LIB space. In terms of applications, in terms of the technology chemistries within LIBs, it was very clear that safety is a much bigger concern than the chemistry when it comes to choosing applications for LIB. Recent fires across battery installations have been pointed out as a primary concern for why safety is going to be sort of the leading factor when looking at various battery chemistries. So within LIB, I think it is going, the group sort of did point out that safety is going to be one of the biggest drivers along with performance, which will determine what type of chemistry within LIB is going to continue. as we move forward to 2030. And I think a significant amount of time was spent on discussing what is the potential and challenges for second life applications of BESS. So we did have refurbishing industries, we did have auto OEMs, and all of them did, from the auto OEM perspective, primarily they did look at residual value of the battery as a major economical consideration within their electric vehicle. Some auto OEMs are already actively discussing and also, I think, testing out the deployment of their second life batteries in stationary storage applications. And this is something that will continue to remain a priority for a lot of the auto OEMs, because given the high initial capex that the customer has to put up front, maybe removing that high capex by getting some residual value back through the second life application of a battery. This could be a way to sort of commercialize or accelerate the commercialization of these battery technologies. Other than that, from the refurbishment side or the recycling industry side, I think one key issue that was pointed out, which was also similarly voiced by the auto OEMs, was that having access to data about how these batteries have been performing, or having access to the BMS on how these batteries have been charged, discharged, utilized, is going to be critical. For the residual value to be estimated, I think it only makes sense that both the stakeholders have pointed out a very, very key factor that needs to be put in play, where even if it is a system needs to be developed wherein the data sharing between the first consumer or the first utilizer of the battery is able to pass on to the second life user, so that they can then not only determine the residual value, but look at how this battery can be used in its second life application. So there were also comments around if there can be an institutional mechanism like how the EU has set up battery passports. If India can also set up a mechanism in place where the ecosystem has access to this data and is able to sort of transact between the first life user and the second life user of the battery. And I think this is something that both sides of the ecosystem are quite interested in sort of taking forward. In terms of specific to Indian operating conditions, Indian operating conditions are unique. Experts did point out that operating conditions will have to improve, and enabling an ecosystem for the operation of LIVs within India is very crucial, as this impacts the lifespan of batteries, which is in essence sort of dictates how viable the project is. And this is going to be very crucial for battery asset developers in the country to be able to understand how operating in an Indian context is going to impact their technology performance. And as this changes from technology to technology across chemistries, it's going to be really important that we are able to get on-ground deployment data to be able to estimate what type of asset degradation are we looking at, or what type of operational conditions can we meet basis the requirements from the off-taker. So that, I think, was some of the key discussion that was a brief of the key discussion points that we had in the breakout session for battery energy storage. With that, I'd like to now hand it back to the moderator. Thank you.
Thank you, Anurag. Thank you, Dr. Parveen. We will now move on to our last section for this workshop. It's a policy brown bag, where we will be talking about the challenges in regulation and implementation of battery recycling in India. Dr. Parveen, over to you for this.
Thank you, Anandita. During our breakout session, some discussion was there around this policy related things. As Anurag also mentioned about the battery data, that is one of the critical things. So Mitadev, can you just share the slide and we'll just discuss the few things and what we want to do in this session. And we want to discuss a few critical things and how we address those challenges. And your input will be really helpful for us while doing the deep dive on the policy and regulation side work. And the complete insight, as I mentioned in the breakout session, will be providing on the 2nd July. when we are by then we'll be able to complete our whole analysis. So some of the basic thing we all know, just for the connectivity, we'll just discuss in 1 or 2 slides. So first slide, you can go into it. So why we need lithium battery recycling in India? So almost all of us know why we are talking about the battery circularity, because this currently, if we just look into the Indian scenario, we can see a lot of adoption in the two-wheeler and three-wheeler segment, and then we are getting um, traction in the heavy vehicle segment, car, buses, and by 2030, we are expecting almost 31% in the BAU scenario. And our lithium and battery market is import dependence, and we are importing from the other countries, and we are doing a lot of efforts to develop our domestic LIV manufacturing industry. And with that, we will be requiring these raw materials, and for that we'll be depending on some other countries. And not only dependence for this raw material, this with the increasing demand for this raw material, the mining activity need to scale at the very large scale, and then that is having its own challenges. So if you just see, at per some estimates, India will be generating around 120 gigawatt hour of lithium ion waste by 2030. And out of this, 59 gigawatt hour will come from EVs. And if we dump these lithium batteries, I'm sure we are not going to do this in future, because we all now understand the value and importance of recycling and resource efficiency. So, but in case if these are getting dumped into the landfill, some of these variants are having toxic element like cobalt and other hazardous chemicals that is going to create a problem for our society. And if we efficiently integrate the circularity, we can ensure the local availability of these critical materials. Currently, only few countries are having these raw materials, and especially if we see the midstream of the LIV supply chain, that is concentrated on a few countries. So if we just ask the question why we want to go for the battery circularity, so one, of course, the material criticality, because demand for these materials are going to increase globally. Then we have the supply vulnerability issues. We know that there is a geographical concentration of the raw material, as well as the extraction, purification, and the manufacturing of the LIV active materials and the cell manufacturing, and the price volatility. So we have seen that in 2020 to 23, there is some price. Before that, we are seeing that there is a consistent decline in the LIV cost, but then there is a sudden increase in the raw material cost that resulted into some increase in the lithium battery cost. So that issues will be there, and we know that price is one of the biggest challenge for the EVs, and battery accounts for almost 40–50% of the total EV cost. So we can understand, and our country is a very price sensitive market. So even 1 or 2 rupees up and down matters a lot. And if we integrate this battery circularity, we'll be able to reduce the primary mining demand, and this will help us in reducing the life cycle emission from the LIV supply chain. If you see on the next slide, that so these are the benefit we have listed, that why we should think of the reuse and recycling. Reuse will help us in reducing the demand of the overall lithium batteries, and recycling will help us in reducing the primary mining demand. And we have listed the what kind of benefit we can expect on the environmental front. So if we go to the next slide, so how we can do this, ways to integrate the battery circularity. So usually when we talk about the battery circularity, we say, okay, after the battery is completing its life in the EV application or BSS, we'll do the end of life recycling. So internally, when we are discussing, we thought, can we think of the circularity from the manufacturing stage itself? So looking into the data, and we found that currently the feedstock for the global recycling industry is from the production scrap. There's a lot of production scrap is getting generated, and so that if we are able to reduce those production scrap and introduce the material efficiency, if we can, then comes the reuse thing. Like we can repurpose the EV batteries for BSS application or any other stationary application. So that will ensure the efficient utilization of the technology for a longer time. So, but problem is there that economic viability of repurposed battery. So one of the major challenges there that the availability of the data from the use phase, and then the design of the battery, the kind of material used for the packaging of these batteries. So this creates challenge for the recycling industry. And then finally, the reverse logistic is the one of the challenge. Like if we just take an example of e-waste, what is happening that almost 1 to 2% we are able to collect and recycle, and huge stock of, these are from some research, that 1 to 2% of retired LIVs from e-waste we are able to recycle. And we almost all will agree that most of the people are not aware what to do with their mobile phones, laptops. Now a lot of players are coming how to manage these things, but reverse logistic is very big challenge for the lithium batteries, even in the e-waste thing, and whether this will continue for the EVs, or we'll be able to resolve this issue and make sure that our collection efficiency is very high, so that we are able to efficiently collect and recycle these materials and utilize for the manufacturing. Then the another challenge comes on the technology front. What kind of, whether we have the efficient technology to recycle, recover those materials at the high purity level, so that these can be used for the active material manufacturing for this like lithium cells. So if we go to, so we basically just, can you go back to the previous slide? So reduce means we are talking about reducing the raw material demand at the manufacturing stage by material efficiency, reuse to extend the life of the application of those technology, and recycle means now when there is no life, we can just recycle, recover those material and circle back into the manufacturing, so that primary mining demand we are reducing, and reducing all the environmental issues associated with the mining and means other upstream challenges. In the next slide, we have captured some of the challenges associated with the battery circularity. And broadly, if we just see, divide some of the challenges in reuse and recycling. One is like, one of the expert was talking about cost of LIVs are coming down, then lack of standardization of for second life battery uses, and then there is a clear gap on the policy and regulation front for the second life application. Even how we take a decision after first life of battery about pushing for the reuse or recycling. And then looking to the, if you just go on the recycling side, chemistry heterogeneity is one of the challenge. Even if you take the example of NMC, there is so many variants with the different composition of lithium, cobalt, nickel, and then developing the market for the recycled material. So even if you recycle the material, and if you look into the India right now, you have, once you recover the black mass, you have to export to the other country. Unless we develop active material manufacturing industry in India, there will be challenge for this recycling industry to scale the recovery of battery grade material and sell within the country. So market development for recycled material is one of the challenges, and then developing a sustainable business model and reverse logistic things. So if we go to the next slide, what we did, we just analyzed that what is happening at the global level. So globally, several countries, they have develop the policy and regulatory framework for the battery recycling. And of course, China is leading on this front. And they have, and that you can see the impact of good policy and regulatory framework you can see in their recycling data. If you look into that, how much they are recycling, how much they are recovering the raw materials, so that is clear from there. So of course that highlight that the gap in the policy, regulation and standards need to be fixed. That will really help us in scaling this discussion or implementation of the battery circularity. One of the example for the data we can see from the UK and European Union, where they have the concept of battery passport they are working on. So that will help us in addressing the issues related to the battery data, especially the technical data. That becomes very critical if you want to take a decision related to reuse and recycling, because safety is one of the challenge, and if you manage, then that is not a challenge. So usually we say ki safety is the issue with the lithium battery. That is not safety. If you know how to use it and how to manage and how to avoid the abuse of the best operating condition, or how you manage the stress factor of the batteries, that will help you in having the safe usage of these lithium batteries. So we have just analyzed the different policy and regulation across the world, and then try to understand that what kind of situation is there in our country. So if we go to the next slide. So in India, we have the battery waste management rule, and we all are aware of this. And then there is some provision in battery swapping policy about unique identification number and data collection and management, and all these things were very enabling suggestion, and that can be useful for the battery circularity. But lot need to be done. So that we all agree that something is there, but to make sure that we have a very robust and stable battery circular ecosystem in India, we need to identify the challenges and gaps, especially related to the policy, regulation and standards and implementation challenge. And then we need to fix it and identify the India specific solution for that. Can you go to the next slide? So here we have listed that we have developed the table just to show how we are placed on the enabling action compared to the other countries. So you can see we have the EPR provision like China, South Korea, European Union, they have the provision of EPR, that is extended producer responsibility. And we too have in the battery waste management rule. Then digital data collection, we don't have. Battery passport system that EU is having, that we don't have. Like that. So we have listed where we are placed in the, if we compare the policy and regulation landscape across the world. So this will help that where is the gap, and something may work in the globe in some other countries, it may not work in India. So this kind of discussion will help us in identifying what we need to do to fill the gaps or to develop our own solution. Can you go to the next slide? So here I have just listed a few few points. And because policy and regulation related work is under progress, so I thought on the some of the critical point, it will be great to get your input, suggestions, and what need to be done, so that we can include in our analysis and present this in our next workshop that is planned in the 2nd of July. So first point is there, like we have the provision of EPR in the battery waste management rule. So what is the status, where we are, whether the implementation of EPR is moving in the right direction, or there is a challenge, or we need to do something so that the EPR implementation become more effective, I see. And then if we talk about in the breakout session, we are talking about the battery data. So what kind of system we can develop if we want to develop the idea of battery passport for India. So what kind of solution we can develop, because it may or may not be possible to develop the similar thing what we have in the other countries, but we can customize and develop India specific solution. Then the reverse logistic, how big challenge the industry see this, and is there any suggestion to make the reverse logistic very robust so that our collection and recycling efficiency goes on the higher side? Then the market for second life LIDs. What is the potential? Where is the challenge? What need to be done if we want to see the second life market for LIDs in India? Then the gaps in policy regulation and standards. If you have any specific suggestion input on this. Then where we are on the technology readiness for battery circularity at the manufacturing stage, reuse and recycling phase. And then finally on the market for recovered raw materials. So we'll go one by one, and please feel free to give your opinion, suggestion on this. Your input and suggestion will be really helpful for us, and that will help us in developing this solution and suggestion, which will be more customized for the India. So I'll just stop here, and then please raise your hand so that we can just invite you for sharing your thoughts on these points. Mr. Dev, you can keep this on the screen. And so please go ahead and raise your hand so that we can continue on the discussion.
Unfortunately, I'm not able to see an option to raise my hand. So please feel free to call out whenever you want me to talk.
No, please, why don't you go ahead? Please go ahead.
Okay, so really good summary, Parveen, and I really appreciate the effort that WRI is putting into this. I had a few basic starting points. Who is going to be the audience for this study? Is it going to be Indian policymakers? Is it just help me understand that?
Yes. So the Indian, of course, this we are developing for the India. So of course, they are the one of the main stakeholder, and also the analysis will be useful for the industry stakeholders also. The data, you'll be knowing that what kind of potential is there from the reuse, recycling, and providing a very comprehensive and realistic picture, whether it's for about the market, about the policy and regulation, and we'll be engaging with the line ministries once we complete this analysis.
Sure. Okay. So okay. So there are 2-3 things. The first is that for different critical minerals, there is a different reality. So cobalt and nickel, we are import dependent. And so therefore, talking about reducing mining of those would not probably be the best strategic lens to adopt. Maybe an overall strategic lens of linking it to India's critical mineral security may speak more strongly to the government's priorities. That's on the overall framing of the solution set. On EPR implementation, I'm sure my colleagues from the industry and my peers would have a lot to comment on. But starting point, EPR is the way it is currently envisaged. There are issues with self-declaration, so the numbers don't match up. And the numbers, because they're based on self-declaration, are not practical. And we would be happy to, flesh that out more in more detail and share it with you. The second aspect of EPR implementation is that a large part of the exercise is actually, while it's the producer's responsibility, it gets loaded onto the recycler. So the collection, transportation, and storage costs, which form a huge significant proportion of the recycling value chain, are not feasible in their current fashion, especially if you want to do things right. If you want to do things in an unorganized sector manner, then lowest possible cost, they will do something, they will collect, they will do whatever they have to do. But if you want to do it in an absolutely safe, non-hazardous, absolutely systematically defined way, then it is an expensive process. The other aspect of this is that LFP recycling is not viable right now. So there needs to be an established floor price for EPR. That is my basic submission on the EPR side. The idea of the battery passport we have discussed in the breakout session. So that is, of course, that is going to really help create the right kind of data bank in terms of traceability and viability of any battery. The reverse logistics is linked to the collection, transportation, storage aspects. And reverse logistics is actually, there are very few players that are able to do it in a fashion that it should be done in. So accounting for that, again, I think I'm reiterating. Second life batteries, there is a huge potential market. There are enough players that have started working on developing products and calculating values and developing softwares. And there is enough interest in the wider ecosystem to pick this up. But it does need, it does need, I would say, technology and innovation support from the government. And so to some extent, some of the schemes that are being envisaged need to have a separate aspect to promote R&D and innovation specifically, with significant outlays. It cannot be just a small seed fund that will do this, because there are enough pilots out there. So from R&D to pilot to scalability, this challenge is going to be in scalability. I think overall gaps in policy, regulation, standards, we've covered enough. One thing is securing feedstock for India. So India is deficient when it comes to a lot of critical minerals. While we do work on developing our virgin mining capacity and developing that whole ecosystem, in the interim at least, or from a long-term sustainability point of view as well, EU as well as US are securing their domestic feedstocks. India needs to have partnerships, FTAs that enable us to get access to that feedstock, because those markets are going to be generating very large volumes soon. We've spoken about technology readiness. Technology readiness is a mix of players across the spectrum, but there is enough high-end capability that is present within India. India is a low-cost R&D innovator, and so there's a lot that is already happening. It just needs support, pump and push for it to become larger and bigger, and for India to dominate the global market. I would like to say that India can take the lead as a global player, and we should not just think of recycling as a side activity or as something that's going to just help manage things. It's not just about managing things, it's actually about dominating the global market, and that is our opportunity. So I'll leave it at this. Thank you for humoring me.
Thank you, Rashiji, for your input. And Gauravji,
No,
you
this
can...
was Bhavna from Loham.
Oh, sorry. Bhavna, thank you. Sorry, I just... sorry. Okay. Gauravji, you can go ahead with your input.
Thank you so much, WRI, for inviting me. Thank you, Praveen. This is Gaurav here from LICO. So, largely agree with a lot of things that Bhavna said. I think we all face similar challenges, and we come across similar problems, and I think we have very similar solutions that we have proposed. So, if I go one by one, I would like to say EPR implementation in India is, quite frankly, quite a disaster. I think the website, the portal that CPCB has made is absurd. The quantities of lithium, cobalt, nickel that they have mentioned on the portal do not make any logical sense. So we have been telling them that the way that the calculations have been happening, or the way that the producers have been entering their metal content, does not make sense. There are certain areas where we have seen producers put lithium content of 40-50% in the batteries, which is just not possible. So there has to be some kind of validation, some kind of verification of what data producers are entering, what data recyclers are entering. And that cross-check or verification is not happening at the moment. In terms of, if I go one step further, that it's quite complicated. There are 7 different metals that they want each producer to know about and enter. Most producers in India have no idea about what metal salts or metal percentages, weight percentages are in their cells. So which is a body that will test it, will verify it, and again, so there are many challenges from the get-go. Now, the implementation has been haphazard, has been sudden, has been in the middle of a financial year, which means that all of a sudden 4 metals can be given, 3 cannot be given, or vice versa. So our suggestion to the CPCB and Ministry of Environment has always been, till capacities of refining do not get built in India, we should give everybody a fair chance to give EPR. It could be assessed annually, and those capacities can be verified, right? Because there are not too many players. Now, in terms of the idea of a battery passport, completely agree. Without tracking and tracing, it will be very difficult for us to go back to BWMR rules and say that 5% of recycled material needs to kick in by 2027. How do we track and trace that this is indeed recycled material? In most cases, material is leaving the country, whether it's black mass, whether it's salts, because there is no anode or cathode processing or manufacturing. So how are we going to track and trace recycled materials? Status of reverse logistics. Yeah, CPCB have mentioned that they are working on guidelines of safe transportation, which is extremely critical. The way lithium-ion batteries are handled at the moment in India is nothing short of a calamity waiting to happen. It is extremely dangerous, and it all boils down to the fact that are producers willing to pay? Everything has been burdened onto the recyclers. We don't have a good formal collection system for batteries. Producers should ensure that, and recyclers are willing to play their part in that. But if without any safe collection mechanism, then we are waiting for incidents to occur. We should be proactive, and we should not wait for an accident and loss of lives to happen before we start implementing stringent rules. Market for second life LIBs is quite dominant. I mean, it's very promising. There is all of us are working in this space. We don't see any challenges there. Gaps in policy, regulation, standards. Yes, we've spoken about that already. We would like to see more regulation towards safe transportation and logistics. Also, to verify how recyclers, how can we verify their methods? I think the CPCB or the Ministry of Environment has a certain guidelines in mind for recycling, but that has not translated down at state level to every single state. I think any of us who have facilities in multiple parts of India can go and tell you that the different experiences we've had with different states. Technology readiness for battery circularity, I think it's still an early stage. Yes, we are all working on circularity. So I think the first phase is collection, dismantling, sorting, which I think we all have figured out. But yes, it has its challenges, given currently the raw material abundance being in the informal sector. And then second part would be mechanical separation, which we're doing as well. I think the third part, which is the refining, the salts, and at that battery grade purity to ensure circularity, has not come in yet, but it's not that easy. It takes time, it takes investment, it takes R&D, and that's where I think our strength is as a country. We are a country which has a very good knowledge of, of a chemical industry. We have low cost R&D, and we can definitely provide that as as an opportunity for our country. And rightfully, as discussed earlier, looking at partnerships for securing raw material, looking at our neighboring countries, looking at countries look at the example of South Korea, how well they've played this out. Their relationship with EU, with Japan, with the US. I don't see India going and doing that on a larger scale. We always are talking about what we can do within India. Yes, all of us are here and we're all doing
Is it me or did we lose Gaurav?
I think there is some problem.
Yeah.
Okay, so just picking up from what he was talking about, G2G
Sorry.
partnerships. Gaurav, are you back?
Yeah, sorry. I think something went wrong. But yeah, I was just saying that, yeah, looking at a government to government push would be very good. I think India should be processing for the world, not only for ourselves. And that's where I think that we should do away with restrictions and be open, look to get as much as raw material in our country. The more raw material you get, the more investments will come in this space, the more investments will go in R&D, capacities will be built, and that's how we are going to compete with any major force. I think that would be it from my side. Thank you for listening to me.
Thank you, Gauravji. Bhavna, you wanted to add something on this?
Yeah, I just wanted to give an example. So, for example, the EU is considering a proposal to classify black mass as hazardous waste. Now, what this will do is it will limit the movement of black mass to OECD countries, which is not a problem for Korea. It would be a problem for India because we are not an OECD country. So, active points for government to engage, and ensure that feedstock is secured for Indian market for us to process and supply to the world.
Yeah, very good point. And I think that we cannot consider these as critical minerals on one hand and then look at it from a waste lens. If these are indeed critical minerals, why are we looking at it as waste? Why are we not looking to bring in as much critical minerals into our country and secure supply chains?
Absolutely with Gaurav on that.
So before I go to Rashi ji, one question I have both for Gaurav ji and Bhavna. Regarding this, we have the more LFP based chemistry, and we can expect these LFP chemistry in big number in our waste by 2030. And we all know that these LFP recycling this LFP chemistry is big challenge because you don't have the minerals like nickel and cobalt, and that creates a problem as far as the profitability is there. But analysis of this literature and all suggest that if we adopt a direct recycling approach, so that will be more cost effective compared to the pyro and hydro approach. So what is your comment on this? That because our recycling industries are now evolving, so whether they can adopt a innovative technology that is more cost effective and efficient compared to this pyro and hydro. I know that direct recycling is at the very initial stage, but your comment on this?
Yeah, so this brings me to my original point around R&D and innovation support. Because this is something that the industry can work towards, figuring out, but it cannot be done in a silo. It cannot be done by one player. It needs a collaboration. More importantly, it needs government to be behind us and saying that this is something we need to figure out as a country.
Yeah, absolutely. I agree. I mean, today LFP recycling is not commercially viable, right? There is no secret here. It's not viable for any of us. So, how do we tackle this, right? Because look, LFP adoption is on the rise, and it's going to be a dominant So we need to understand how can we tackle this. Well, in LFP, the only real recoverable metal of value or mineral of value rather is lithium. And so the price of the entire store
I think
there has to be
some,
certain EPR base, especially base price for LFP, especially.
thank you, Gaurav ji and Bhavna ji for your input.
So just
Now
to add, Praveen, we are talking about an EPR floor price for it to be viable to recycle irrespective of the kind of chemistry. Lithium prices are not where they used to be globally 2 years ago. They are they seem to have come at a steady state below $20 per kg kind of level. So keeping these numbers in mind, it'll need to be a long-term view that we take on promoting and enabling recycling. So EPR floor price is a very, very critical need of the hour.
thank you, Bhavna ji, for your input. Now, Rasi ji, you can share your input. I know you're waiting since a long time, but please go ahead.
Yeah, I completely agree with what Gaurav ji and Bhavna just said. The EPR implementation needs to be seriously looked into by the government, you know. It's no less than a harassment, actually. And so what happens is, you know, the industry suffers because of these delays that that the government authorities do, and then they expect the industry to comply to everything, and you know, things have been really bad with EPR. I mean, that is what I'll have to say. When it comes to idea for battery passport for India, I don't think battery passport can be as it is adopted for India. It is not going to work with the kind of culture and the kind of infrastructure that we have. I would also add the word attitude that we have in our country. So, you know, those three things, until unless we change, I don't think a battery passport can be directly adopted. We will need to do something very innovative for our country because our requirements are completely different from that of Europe. Second thing is, I also would want to say that since LFP is completely, LFP is dominant at the moment, and you will see a lot of battery chunk coming out in the next 2 years. So how and what are we planning exactly to have this waste or unusable battery? I mean, most of them will not be even second life worthy. They will go for recycling or dump yards. How do we plan to actually take over that, that chunk of waste that is going to come out? There is nobody talking about it. There is nobody thinking about in that direction, or at least they are not vocal about it. I don't see that happening. So that is one important challenge that I see here. In terms of gaps in policy, regulation, and standards, we are not talking about skills anywhere. Praveen ji, I know how much you advocate skills, but if you talk of circularity, skill circularity is also important, and that is not highlighted anywhere. So skills have to form until and unless we keep harping on them continuously in every in every policy or agenda or anything that we put forth to the government, things are not going to move in that direction. So that is also very, very important. And definite now, see, when you talk of market for the recovered new materials, I see a problem there because we are not per se manufacturing in in depth in India as of now. The full scale manufacturing, right from the coating lines to making the anode and cathode, is still not happening in India. So I see a challenge there for the recovered raw materials as of now. But if the manufacturing scales up really under the new schemes, the PLI and the announcements that have been made, you could have a significant market for the recovered raw materials based on the content and the purity that is coming out of recycling. So there is a lot of gap in the policy. EPR implementation is very poor in the country. I mean, to get a certificate, it takes you at least 6 months when their website says it's 15 days. And the harassment in the customs and the EPR officers are next level. It's really next level. Something has to be really told to them to, and nobody is accessible on any of the email IDs or phone calls or anything. The scientists are also, I mean, the so-called scientists at EEB and sea level are really not accessible. It's a bad state of affairs, really bad. I mean, I agree with what Gaurav just said. I mean, I still have mellowed it down, but it's bad. So somewhere, if something goes out to them, it's important. And when they and in the many of the sessions that these people visit, they tell us that industry, they are watching you, and you have to be really careful of what you're doing and how returns are filed. But the system doesn't work. Where are we then? So technological gaps are also there, which needs to be, assessed. Also, one more thing that had come up in the discussion was access to data. There is no access to data anywhere. I mean, even if an NDA is signed or even if, agreements are signed, access to data is a very big challenge as of today, which needs to be addressed because people are not sharing the data. Maybe they don't have the data. So somewhere that access to data is important, and at least bare minimum access to data is important to understand what is the state of the battery to actually really use it in the second life application and not to land up in a hazard again. Maybe it did not have a hazard in the first life, but if you don't know what happened to it in the first life, if you do not have access to data, it could potentially become a hazard in the second life. So that also needs to be addressed. So these are my points as of now. Thank you so much.
Thank you, Rashiji. Actually, in this, we highlighted only few points which we thought let's take the input on some pain points, what we have identified while doing the research. So we often see the suggestion for battery passports. So we're thinking how to, if we have to think about this for India, then how it will look like, keeping in, as you mentioned, about the attitude and approach people are having, and the cost that comes when we talk about the data collection and management. So ownership of data and who will bear the cost and all these things will come into the picture. So more detailed discussion we'll do on next workshop. But thank you so much for sharing your input. Any other comment and suggestion from other experts? EV OEMs and others who want to provide their input, especially related to battery data.
So can I just chime in here, Praveen?
Yeah, please.
So I really appreciate the inputs that Dr. Rashi has also shared. But personally, I feel even EPR implementation to begin with was an attitude problem. Why would anybody want to take on the additional burden of disposing of something responsibly? So battery passport related data and information, when producers are, and I'm sure anybody who is a producer would be maintaining such records, at least internally. It's just about creating that enabling environment for them to share it. In Hindi, we have a saying, in Sanskrit, we have a saying, Sam, Dam, Dan, Bhev. Whatever it takes, it can be implemented. We just have to have the will for it as an industry to adopt it and as administrators and government to implement it.
Yeah, so that's why we are doing this discussion to get solution where everybody must be happy to adopt that. It should not be unilateral that government is telling something and industry is expecting something. So like EPR is there, of course, we have seen this in the Europe, UK, China, and in our battery waste management rule also we have the EPR. But what we were thinking that on ground implementation is another challenge. and how this, what kind of actions can be taken for the EPR where each stakeholder feels that they should comply with that instead of feeling this as a burden.
Absolutely agree. On EPR, there are other aspects from a technical point of view which Dr. Rashi touched upon, which are very, very pertinent. For example, you do one incorrect transaction and you are stuck with it. It doesn't, there is no option to call back on the transaction. So as we are adopting these changes, I think also ensuring that there is some thinking that happens within the government on creating scope for people to comply. So not just comply, but also, trying to do it right, in a very sustainable manner. For every little thing, one cannot be running back to CPCB. So some internal thinking
I
needs to
agree
happen.
with Bhavna, compliance cannot be on a gunpoint. The way these people behave, it's like on a gunpoint.
So yeah, just I think some brainstorming, maybe, some thinking through in terms of when they're looking to roll out changes, maybe some kind of alignment. And it doesn't always have to come in from industry. There are enough best practices that exist in the world which can be adopted in India. So that bit of, I- for lack of a better word, homework, instead of just doing it.
Thank you so much. Any other comment before I hand over to Anandita for the concluding session? Anybody wants to provide the input, any comment, any suggestion? Overall, also if you want to comment. I think we don't have any more comments. Anandita, over to you for the final session.
Thank you everyone. Would request Reneni to please do the concluding remarks before we finish the workshop.
Thank you, Anandita. I think we now have very few of our participants left, but I guess throughout this session, we got some very, very good inputs for our research as well as for continuing the research that we're doing on the policy aspects and how to ensure that recycling ecosystem can be made more sustainable. And we will be incorporating all of these insights in the technical research that we are doing as well as in the policy research, and we will be presenting our final research in the next workshop that we are going to have, that is on 2nd July as a part of the India Energy Storage Week. And we hope to see all of you in that workshop as well. And in that workshop, we will also have a more elongated discussion on the whole policy and regulatory aspects and challenges regarding battery circularity. And it would be really helpful if we get all your inputs in that workshop as well. So hope to see you there at the IESW workshop on 2nd July. And thank you so much for each and every one of you for attending today's workshop as well.